Alright, this is the Topic 8 Quadratics Part 1 study guide. So number 1, we have the polynomial 14x to the third minus 7x squared plus 90x. And question 1 says, what is the degree? Remember, the degree is how many variables each term has. So x to the third is x times x times x, so that's a third degree. 7x squared is x times x, so that's a second degree, and then x is just a first. So you would think that maybe we should add all of them together, but we don't. Actually, what determines the degree is the highest number we see. So third is the highest number we see, so this is called a third degree. Question number 2 says, well, is this a quadratic? Well, the answer is no, because in order to be a quadratic, you have to be a second degree polynomial. And since we have a third degree, we no longer have, or never did have, a quadratic. On to number 3. Number 3, we are finding the sum or difference of like terms. So like terms means you can only add them together if they're the same. For example, apples plus tomatoes don't give you apple tomatoes. You've got to have the same thing. So the first thing we have to do is get rid of those parentheses. So we distribute a positive 1, which would give you a 4ab plus a 2h to the third minus a 5h squared. Then we go to the second parentheses. There's a positive 1 in front of there as well, so we distribute the 1 in, which doesn't do anything. It just keeps everything the same because you're distributing a positive. So now we look for like terms. This is an AB term, so I look for any more AB terms, which we have. So I have 4 of them plus 17 ABs. That's like 4 apples plus 17 apples gives you 21 apples. We don't change the variables though, because you're making the quantities increase, not the variable themselves. So the variables, we don't touch them when adding or subtracting. Then we take a look. I've got an h to the third, and I have another h to the third. So this is a positive 2 plus a positive 4, which is a positive 6. So we write plus 6h to the third. Then I look, I have an h squared. Well, I don't have any other h squared, so it just stays minus 5h squared. And I've got a minus 2a, which can't go with anything because there's no other a's. And notice a, b, and a don't go together because they're different. One has a b and the other doesn't. Now 4 is the one that's a little bit trickier because this is a subtraction problem. And I always and strongly recommend that when doing this problem, you get rid of your parentheses first. So in order to get rid of the parentheses, on the first part there's a positive 1 in front. So that's going to give me 5w plus 3w squared minus 9. Now pay attention, on the second parentheses there's a negative sign in front. So when you distribute that negative to everything inside, everything turns opposite. So you now have a negative 7w squared, now a positive 2w, now a negative 4. So now we take a look at what can go together. I've got 5w. Now I have w squared, so those are different. They can't go together. So I have a w over here. It's just like red apples and green apples. They can be similar, but they're not the same, so we can't put them together. So 5w plus 2w is 7w. Then I've got a positive 3w squared and a negative 7w squared. So 3 plus a negative 7 is a negative 4. So negative 4w squared. And then finally, I've got a minus 9 and a minus 4, which makes a minus 13. And then if we want to write it in the correct order, standard form, it would be negative 4w squared plus 7w minus 13. But it doesn't say that it has to be written in standard form. Now we're on to the multiplication. R minus 8 times R minus 5. Most people use the box method for these, so I'll use the boxes throughout this study guide. So you put your first binomial on the top, or it can be on the side, it's your choice. Your second. And now you just fill in your boxes. R times R is R squared. R times negative 8 is negative 8R. R times negative 5 is negative 5R. Negative 5 times negative 8 is positive 40. Now we put together the like terms. We have some R's that are like terms. So those go together. So negative 8R's and negative 5R's make negative 13R's. Then you've got your plus 40 and your R squared from the beginning. Our next one, we have 3d minus 9 squared, and this one, please, please, please pay attention to. This is the most missed question every year on this test. because a lot of people think that 3d minus 9 squared, they just think that you square each thing. They think it's 9d squared minus 81, which it is not that. And here's the reason why. When we write 3d minus 9 squared, if we write that the long way, that's really 3d minus 9 times 3d minus 9. So now let's use the box and see what happens. 3d minus 9, 3d minus 9. So here we go. 3d times 3d is 9d squared. And you're going, well, that's what I had to begin with, 9d squared. Negative 9, positive 81. 3d, negative 9, negative 27d. 3d, negative 9, negative 27d. So now let's put together our like terms. Well, a negative 27 and a negative 27 make a negative 54d. Then your plus 81, and then your 9d squared at the very beginning. Number 7, back to another box, 2m plus 7, 2m minus 7. So 2m plus 7, 2m minus 7. 2m times 2m is 4m squared. 2m times 7 is 14m. 2m and negative 7 is negative 14m. Negative 7 and 7 is negative 49. Well, this time when you combine your like terms, they cancel out. So you're left with 4m squared minus 49. Number 8, you're having to find the area of the shaded region. Well, this is like your old elementary school problems. Like they would say you have a box that's 8 by 4, and then you have a little box inside that's 2 by 1, and you got to find the shaded area. So you would find the area of the whole box, which is 32, and then subtract what you took away from the box, which would be an area of 2, which is 30. But we make it in terms of algebra. So instead of an 8 by 4 box, we're giving you a 3x by x plus 2 box. So if we want to find the area of this original box, we would do 3x times x plus 2, which gives us 3x squared plus 6x by using our distributive property. Then we have to take out the box in the middle because we're looking for the shaded area. So the box in the middle is 2x and x. And if you don't have your study guide in front of you, this is all the shaded stuff around it. So to find the area of the inside box, that's x times 2x, which is 2x squared. Well, just like up here when I did the whole, which was 32, minus the box in the middle, which was 2, same thing. We're doing the whole, which is 3x squared plus 6x, minus the little part, which is 2x squared. And if we combine like terms, that gives us 1x squared plus 6x. And obviously the 1 does not have to be in front. Now on to factoring. So on factoring, I'm going to say this once in the video and write it for you, and I'll refer back to it because I don't want to have to keep writing it every time. There is a process for factoring. The very first thing you always look for, so we call these the factor tools. The first tool you always look for is the GCF tool. If you can use it, use it. Then you move on to the factor by grouping tool. If you can use it, then you use it. Then you move on to the diamonds. You've got the regular diamond and what I also refer to as the big diamond. And finally, the last thing in your toolbox that you check is the difference of squares. So for every single problem that I do in here, I will go through all 4 of these and check them off. So let's start with number 9. Number 9 has 10x squared plus 15x. Rule number 1, GCF. Yes, we have a GCF because there's a number that goes into 10 and 15 that isn't just a 1. And the biggest number that goes into both is a 5. Then they also have x's in common. So this first one has 2 x's, the second one has 1. So if we say how many do they have in common or they share 1 x in common. So that's what we pull out. So the 5x is going to be on the outside. Now to get your insides, you divide your original by your GCF. So 10x squared divided by 5x is equal to 2x. 15x divided by 5x, x's cancel, is equal to 3. So you get 2x plus 3. Now my leftovers, I check, is it factor by grouping? No. Can I use a diamond on this? No. Is it a difference? No, because there's an addition. So GCF was the only thing. Number 10, we have 18x to the 7th, y to the 3rd, minus 30, x to the 3rd, y. So we start with GCF. And again, we have one. The biggest number that can go into a 6 as well as into an 18. The biggest number that goes into 18 that also goes into 30 is a 6. Then we look at x's. This has 7, this has 3. So the most that they would have in common with each other would be 3 of them. Now we look at their y's. This has 3, this has 1. The most they share in common is 1. Now we get the inside, so we divide. 18 divided by 6 is 3. X to the 7th divided by x to the 3rd is x to the 4th. Y to the 3rd divided by y is y squared. Negative 30 divided by 6 is negative 5. X to the 3rd divided by x to the 3rd is nothing. Y divided by y is nothing. And when I say nothing, it's really 1, but we're not going to put a 1 there because we already have a 5. Now I look at what I've got left over. Factor by grouping, nope. Difference of squares, diamonds, none of it works. Only GCF worked on that problem. On to number 11, y squared plus 7y plus 6. Start with the GCF. Don't have one. So now we move to factor by grouping. No, because remember, factor by grouping, and I'll come back to the top, factor by grouping has to be 4 terms. And then for these diamonds and big diamonds, it always has to be an x squared, x, and a number. And then difference of squares always has to be a subtraction of 2 things being squared. So we don't have GCF, but we do have a diamond because we have a y squared y and then a whole number. And the way the diamond works, and you don't have to use a diamond, it's just what we call it, we are looking for 2 numbers that add to give us the 7 and multiply to give us the 6. But some people like to put that in a diamond organizer where you put the add number on the bottom and the multiply number on the top. We use the word BAMT to help us remember what goes where. B in BAMT stands for bottom, A stands for add, M stands for multiply, and T for top. It's a stupid word, but it helps us remember what goes where. So now what 2 numbers add to give you a 7, multiply to give you a 6? So you can just start with the very first number that multiplies to give you 6, which would be 1. So then would 1 and 6 add to 7? Sure does, which means we are done. The side numbers become the numbers in your parentheses, and the first term is always just your square root of the first variable, which is a y. And then there's nothing we can do. Difference of squares didn't show up, so we're done with that one. Next one, I know it's in terms of a's, but I'm going to draw it as x's. So x squared plus 8x minus 48. GCF, no. So factor by grouping, no. Diamonds, yes, because we have an x squared, x, and number. So we need to figure out what adds to 8 and multiplies to negative 48. So for those of you that use the diamond, the 8 goes on the bottom, negative 48 on the top. So I'm multiplying to get a negative. So I know that one has to be positive, the other has to be negative. So we just start through the list. I could do a 1 and 48. Well, that's not going to work. 2 goes into it next. So 2 and 24. Not going to give me an 8. Will 3 go into it? Yes. I could do a 3 and a 16. That's still not going to be a difference of 8. I could do a 4 and a 12. We might have something there. If I use a positive 12 and a negative 4, when I add those, I get a positive 8. So we hit the right thing. X plus 12 and x minus 4. Moving on to number 13, we have x squared minus 12x plus 48. GCF, no. Factor by grouping, no. Diamond, yes. X squared, x number. So add, multiply. Add negative 12, multiply 48. So we start the process. 1 and 48. Oh, also the signs. Let's figure out the signs. When I multiply, I get a positive, but I add, I get a negative. So they have to be 2 negative numbers. So 1 and 48, not going to work. Well, you know what? We've already got 48's done. We did that on the last problem. So let's go back to it. So do any of these numbers add to give me a negative 12 if both of them were negative? So far, no. But let's keep the process going. So 5 doesn't go into 48. Does 6 go into 48? It does. 6 goes into it 8 times. And 6 plus 8 is equal to not 12, but a 14. So none of these numbers work. So normally we're used to writing down no solution, but in this case we write down the word prime. Prime means you can't factor it using whole numbers. All right, moving on to number 14. We have 2x squared plus 5x plus 3. GCF, don't have one. Factor by grouping, no, because we don't have 4 numbers or 4 terms. Diamond, yes, it would be a diamond, but this time there's something different. Notice here how there is a 2 in front. This is big diamond factoring because of this number. And again, if you go to your OneNote and go into topic 8, section 1, where we talk about big diamond factoring, I've got the 5 steps in very good detail of how to do it. So I'm going to go through it fairly quickly because I can't spend too long on this one. So what we do, your add number stays the way it is. Your add number stays of 5. But what used to be your multiply number, which would be a 3, now it's not going to be a 3. Now it's going to be 3 times the front number. So the front number is a 2. So that's going to change our multiply number from a 3 to a 6. That's always been happening, but up until now there's always been a 1 in front. So when you multiply by 1, this number never changed. Now we fill in the diamond like always. So 3 and 2, add to 5, multiply to give me 6. But here's where the new step comes in as well. You have to turn your original into 4 terms. Well, we've got 3, so how are we going to do 4? Well, look at the 3 and the 2. 3 and 2 put together make a 5. So that's going to be your 3x and your 2x. That makes your 5x. We drop down the original 2x squared, drop down the original 3. Well, now the question is, well, what do we do here? Because we haven't done it yet on the study guide until right now. Now we do our factor by grouping. And the way factor by grouping works is we take our 4 terms and we split it right down the middle. Now what we do is GCF factoring. So this one method has everything wrapped into it almost. You've got the diamonds, you got factor by grouping, and now we're back to the GCF. So the GCF of this is only a x. So you have x and then a 2x plus 3. With factor by grouping, whatever you get in your first parentheses group, you have to use it in your second parentheses group. So can we put a number out here to get back to 2x plus 3? Yes, we can use a 1. And you've got your 2 groups. You've got your outside group, which is an x and a 1. And you've got your inside group, which is a 2x and a 3. On to question 15. 15, we have 3x to the third minus 12x squared plus 2x minus 8. So first things first, GCF, don't have one. Next is factor by grouping. Yes, we do have factor by grouping because we have 4 terms. So let's split it right down the middle. 3 and 12, the biggest thing that goes into it is a 3. X cubed, x squared, we could pull out an x squared. Then we get our insides by dividing. 3x cubed by 3x squared is x. Negative 12x squared by 3x squared is negative 4. Again, I've got x minus 4 there, so I have to use it over here. So what times x minus 4 could give you 2x minus 8? Well, that would be a 2. So we've got our outsides, which is 3x squared plus 2, and we've got our insides, which is x minus 4. On to number 16. We have 8x squared minus 200. First rule of factoring, GCF. Yes, we have a GCF this time. We have a number that will go into 8 and that will also go into 200. The number that we can use here, we could see if 8 would go into 200 and 8 goes into 200. I think that might work, so let's try it out. So 200 divided by 8. 8 goes into 20 twice. 16, bring down the 4, bring down your 0. 48 goes into 45 times. So yes, 8 goes into everything. So we pull out the 8, and now we have x squared minus 25. And then sometimes we think we're done, but we got to go through the list. Factor by grouping? No. Diamonds? No, because we're missing the x term. So the last thing to check is difference of squares. And lo and behold, that's what we have. We have a difference, and both of these terms we can take their square roots and get whole number answers or whole variable answers. So that's exactly what you do. It's called difference of squares because you actually take the square roots. So the square root of x squared is x. The square root of 25 is 5. When you multiply, you have to get a negative. So that's why one's a positive and one's a negative. And don't forget to bring down the 8 from your original GCF. 17, we have x cubed minus 7x squared plus 12x. First step is GCF. We've got one. It's not a number, but it is a variable. They all have at least one x, so we pull it out. We then get x squared minus 7x plus 12. Factor by grouping is next. We don't have it. Diamond, yes, because we have an x squared, x, and number. So we're looking for a number to add negative 7, multiply 12. So add negative 7, multiply 12. We're adding to get a negative and multiplying to get a positive, which means the two numbers have to be negatives. And those two numbers would be a 4 and a 3. So we have x parentheses, x minus 4, x minus 3. And then we don't have difference of squares after we were done, so we finished the factoring on that one. 18, we have 16h squared minus 81y to the 4th. We look for a GCF. We don't have one. Diamonds, no. Factor by grouping, no. But what we do have, again, is a difference of squares. Because the square root of 16 is 4. Square root of h squared is h, because h times h is h squared. Square root of 81 is a 9. Square root of y to the 4th is y squared, because y squared times y squared is y to the 4th. We make one a plus, and then in our other one, we make a minus. On to 19, 4x squared plus 9. GCF, no. Factor by grouping, no. Diamonds, no. Difference of squares, we do not have. This is a sum. So this is prime. There is nothing we can use. But a lot of people think it's difference of squares, but if you look at it just regularly, you see it's a plus sign and not a minus sign. Number 20. We have 25, h to the 3rd, plus 30, h squared, minus 30h, minus 36. GCF, don't have one. Factor by grouping, yes. So we split it right down the middle. GCF of 25 and 30 is 5. H third, h squared means you pull out an h squared. Then your inside is going to be a 5h plus a 6. If we got 5h plus 6 there, we have to get 5h plus 6 over here. What times 5 is negative 30? Well, that would be a negative 6. Negative 6 times 6 is a negative 36. So we've got our outsides, which are 5h squared minus 6, and our insides, which is 5h plus 6. 21, we've got 6x squared minus 7x minus 3. GCF, don't have one. Factor by grouping, no. We have three terms. We've got an x squared and an x, so it's a diamond. But we've got the 6 in front, so it's the long, big diamond. So remember, the add number stays a negative 7. Your multiply number is the one that changes. It changes to that number times the front number. So that's a negative 18. So there are two numbers that can do that. A negative 9 and a positive 2. Add to negative 7, multiply to negative 18. Usually after you're done with the diamond, you're completely done. But with the big diamond, you have to go through the long process. You need to transfer into 4 terms. Remember, to get that extra term, that's where these two numbers come into play. The negative 9x and the positive 2x is what's making up your middle term. Bring down the first, bring down the last. Now we move into 4 terms, which automatically means it's factor by grouping. GCF here is a 3x. Then we get a 2x minus 3. Then over here we have 2x minus 3 again. So what do we multiply 2x by to get a 2x? That's easy, just a 1. So our outside group is 3x plus 1. Our inside group is 2x minus 3. 22, a lot of people are having difficulty with this. We give you the area of a coffee table, and then I give you the length, and they ask for the width. Well, if you think about it, let's just draw the picture. So here's the area, t squared plus 7t minus 8. and the length is t plus 8. Well, the width means you have to multiply t plus 8 times something to get this. Well, this is just a factoring method in disguise. So what adds to give you 7 and multiplies to give you a negative 8 is what we're really asking you. And if you do an 8 and a negative 1, they add to give you 7, multiply to give you negative 8. So your missing dimension was t minus 1. So really, 22 is just another factor problem. You just had to think about it because you were looking for the missing factor, the missing multiplier. 23, what's wrong is they don't have the middle term. They did the common student mistake that people do on page 1 that I said is the most missed, which is why I put this on the study guide and the test to help remind you to go back and fix it from page 1 when you take the test. When you have 2x minus 3y squared, remember that's really 2x minus 3y times 2x minus 3y. So don't try to take a shortcut here. Put it in the box and you'll see that they forgot the missing middle. 2x minus 3y, 2x minus 3y. So let's multiply. That's a 4x squared, a negative 6xy, a negative 6xy, and a 9y squared. So let's combine like terms. 4x squared, negative 6, make negative 12xy, plus 9y squared. And finally, the last one, simplify the square root of 44. I'm going to do the tree method to start with. Actually, this one I will do the perfect square method. So multiply to get 44, but one of the numbers you use, you have to know its square root. So the square root numbers you know, you can just write them. You don't even have to memorize. Just write a number squared. 2 squared is 4, 3 squared is 9, 16, 25. So you know the square roots of all these numbers. Can any of these numbers multiply to give you a 44? Yeah, the 4 can. 4 times 11 would give you 44. Well, what's the square root of 4? It's a 2. Do we know the square root of 11? Nope. So we just leave it like that. 2 root 11. That's the perfect square method. Now 25, our last one of the study guide, I will do using the tree method. You take 120 and you do what you did in elementary school. You make a prime factor tree. So any two numbers that multiply to give you 120. I think of a 10 and 12 right away. Now I break 10 down. That could be a 2 and a 5. 2 and 5 can't be broken down any further because you would just use a 1. So I'm done there. 12 could be a 2 and a 6. 6 could be a 2 and a 3. So now what we do is we write all these numbers under the root sign. And I like to organize them. So I got 2, 2, 2. I got 3 2s, 1 3, and 1 5. So how does this help us? Well, when I look, square roots are all about multiplying two numbers that are identical. So that's what you're doing, looking for identical pairs. And here's one of them. 2 times 2. Well, 2 times 2 is really a 4. Well, what's the square root of a 4? It's a 2. So we pull the 2 out. Now these guys don't have any pairs or partners, so what do they do to each other? Well, they do what we did. They multiply. 2 times 3 times 5, which is 30. And 2 root 30 would be your final answer for that one. Also, for the last thing, if you finish the test early on Tuesday and you've got extra time before you turn it in, please go back and check your work. For example, let's say you weren't sure if x plus 1 times 2x plus 3 was really the right answer to our 2x squared plus 5x plus 3. Well, it's really quick to check. Just set it up in a box and multiply x and 1 and 2x and 3. So x times 2x is 2x squared, 2x times 1 is 2x, 3 times x is 3x, 3 times 1 is 3. There's your 2x squared. Your 2x and 3x make the 5x, and there's your 3. Don't do the checking, though, until you finish the test, because if you try to check every question after you finish it, you might run out of time to take the test. I hope this video has helped.